Alright guys, so I'm trying to do this problem. Word search. Given an M-crossing grid of characters, board, and a string word, return true if the word exists in the grid. The word can be constructed from letters or sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter may not be used more than once. Alright, so basically a 2D grid and we have to find for a specific word. Interesting? Okay. So we can go left to right, we can go right to left, we can go down or we can go up as well. Anything is fair game, right? Yeah. Okay. Some limitations. M and N. So what are M and N? M is the length of the board, N is the number of columns, and we see okay. So it's both are between. So it's maximum like a 6x6 grid, and the word length is 15. So these limits are pretty. I mean not that big. Let's try to do some sort of a brute force approach. So obviously, I can think of as like, hey, let's look at all possible strings that I can, all possible words that I can make of the length equals to the length of the word, and uh, see if that matches with this. Now, the problem is, how do I make a word from the grid? Because from any point, I like if I'm at F, I have multiple options. From F, I can go to B, I can go to C, I can go to D, and I can go to S. There are four different directions that I can go. And then from B again, again four different directions. Oh, okay, so from every other point, there are three different directions because you can't go back to the one from where you came from. Okay, so for everyone else, there are three different directions. And it's not like just another three. So let's say you go from F to B, B to C, C to C, then you can't come back to F. So you need to keep track of the nodes that you visited. So it's sort of like a graph traversal. You start from each and every point, traverse the graph in all the four directions, and you do this till you form this character, right? And if you're not able to find, you keep on breaking. Let's try to write that approach. So we have to basically do some sort of graph traversal and we have to also backtrack because um, so basically if I try F, B, C, C and let's say it does not work, then I want to try F, C, right? Basically when I want to try the different direction, then this node is no longer visited. So when I visit and if that path does not work, then I have to clean up that visited bit so that I can go in a different direction and visit that node from there. So based on all this understanding, okay, what if the word is an empty string? Is it allowed? Let's see. Has at least one line, so that is good enough. So we definitely need something called as a visited. So Boolean array visited is new Boolean array of bow.length and columns is 0. And I will try from all the different, the starting point can be any of these. So I equals to 0, I less than go.length, I plus plus. Okay, so now we want to start from here. Let's say if we start and we find, so we do find board uh, starting from ij, and I'm looking for word. Let's just do this, right? Okay, this visited has to be used, so let's pass in this visited as well. If you find, then we return true. If we don't find from anywhere and we keep on trying from everyone else, then at the end we will return false. Okay, so let's implement this find function. So it's boolean find. So we're passing in ij word and this boolean array visited. Okay. So what are the things to check? Well, first things to check is the size and they are getting should be within the limits. So if I is less than 0 or j is less than 0 or I is greater than equals to length, j is greater than equal to board dot okay, board of 0 dot length, then we return false. Now we can continue only if this I and j is matching with the basically the character. It can be considered as a starting character. So if board of I and j is not equal to the first character, then also we will return false. And now everything in this is good. So at this point, we mark it visited. Consider this is good. And at the end of the traversal, because you're doing backtracking, if let's say um, boolean return value is something, initialized, let's say false, okay, or whatever, and we will before returning we will mark this as false. So yes. Yeah. Now, how do you implement this? So basically here what I found is the character that we want to start with is matching with the first character of the word, which is good, and then we move in 4 different directions. So it will be okay. So we'll call find recursively. Now we'll call. So there are three. One is I can call I plus 1j word visited, but now not the first character. We're not interested in the first character, like we're not interested. What is this I? It was 0, right? So we're not interested in uh, the first character anymore. We have so we move on to another character, so we have to pass on that index, which index we are looking at. uh, so here let's say we say this is a starting point and we call, let's say, x. So we have dealt with the index x. Now we want to in the word the index is now x plus 1, so we call this x plus 1, and here we check character at x. So yeah, so the first character in the word, yeah, basically whichever index we are in on the word that matches, and so it would be this, or there are 4 different paths. So either this or I j plus 1 or the x plus 1. We could go I minus 1j, and we can also go ij minus 1. All right. Then how do we break out though? How do we know when the word is done? So when this x, if the word is done, that means you would be you're outside. So we can add this condition if x is greater than or equal to word dot length. That means we have found it. We return true. In all other cases, return based on this condition. Yeah. All good. So anything else? Let's quickly do a walkthrough for this array. So we will start from A. We basically start from all the guys. The A is the first we start with A 0 0, and this does not satisfy this. X is 0. All of this is fine. It matches the character, so we mark visited as true. This guy is visited. Now we can go in different directions. And let's pick up the direction. So we go in this direction. First, now this second character in the word is not matching with this, so it will return here. So one more condition that I'm missing is this is not visited. So if from A to B, let's say you can't from B, you can't go back to A, and that we can't handle here. Um, I guess here, if visited, if it's already in the visited path, then we return false. Because these three are all false, maybe we do some sort of let's combine them, this or yes, these. If any of these happen, we return false. If this happens, we return true. Not visited. Yeah, so from A to B, it will go from B. It has four directions. In direction of A, it won't. When it goes visited, will block it. When it goes in F, this condition would block it. When it goes above, it will be outside of the boundary. C will then match, and then similarly, all four directions it goes, it will go. Yeah, okay. So let's run and see if it works or fix any compilation errors. Okay. So line number 11. Okay. Return true. Run all test cases. Okay. Submit. Okay, it works. Now talking about the time complexity of it. So what are we doing? We are traversing the end. First of all, we are trying in the worst case, right? We will try our starting point to be any. Let's first define three different things, right? Am, rows and columns, and let's call W. Okay, W equals to word length that we are searching for, right? So firstly, the starting point, we are trying each and every grid, so M cross N, and what is the time complexity of this find? So in this find, let's say we were looking for, uh, let's say we were looking for a two, the word length was just two, right? So what would happen is we go to the first character, right, whenever it matches, and from that we go in four different directions. So if the word length was two, we would just look at it four times. If the word length was three, then from every point we have go in four directions, and then from all those four also we go in again four directions. So it's like a chain reaction, right? It's like an exponential. So if word length is two, it's four. If word length is um, word length is three, that means one you match, and then you go here, so it's four, and then from each of those four there are another fours, right? So four, and each of, so I don't know how to, so basically it's like so once you do there is these four, and from each of those four you go in another four directions, right? So it becomes 16, which is like 4 squared. So it's essentially how many verse iteration that you need is word length minus 1, right? So it's sort of exponential on word length. So this is sort of the time complexity. To just simplify it, minus 1, it's basically m times n times 4 to the power w. Yep, so that's the time complexity. All right,